Okay, guys, today we are looking at the section that is on unusual solutions with inequalities. Okay, so when we have an unusual solution, obviously it's called an unusual solution because it's not something that we're used to seeing. Okay, so the way this is going to work is you're going to end up getting no variable. When you end up with no variable, that's how you know it's an unusual solution. And remember what a variable is in math. A variable is really just those letters BC, X, Y, N, B, right? Okay. So if you end up in a situation where there's no variable, it's going to be an unusual solution. Okay. So if it's a true statement with no variable, it would be all real numbers. And if it's a false statement with no variable, it would be no solution. Okay. So if it's false, it's no solution. If it's true, it's all real numbers. Okay, so let's look at some examples. So the first thing we want to do with this first one, I have negative 5 times x plus 2 is less than negative 5x minus 14. I'm going to distribute this negative 5 to the x and the 2. I'm going to get negative 5x, and then negative 5 times 2 is negative 10, is less than negative 5x minus 14. This stuff's not going to change. I didn't do anything with it, so it's not going to change. Now I need to move my variable, right? And the way we do that is we're going to move our variable to the left side. So I add 5x to both sides, and I notice that negative 5x and 5x are going to end up canceling each other out, okay? So right away I should notice I don't have a variable anymore, which means I'm going to have an unusual solution, okay? So when I get this unusual solution, what's remaining is what I need to look at. I have negative 10 is less than negative 14. Well, is negative 10 less than negative 14, okay? And sometimes these negative numbers can maybe be tricky for us. So I want us to always be thinking about a number line. Okay, is negative 10 more left on a number line than negative 14, or is negative 10 more right on a number line? Because if it's more right, it's going to be greater than, but if it's more left, it's going to be less than. Okay, so negative 10 is not less than negative 14, so that's false. So our unusual solution that's tied with a false statement is no solution. Okay, so this first one we ended up getting a no variable. We know that this is a false statement, no solution. Okay, for the next one, okay, the first thing I want to do for number 2 is I want to distribute this 2. Okay, so I have 8 plus 4x is greater than or equal to 2 times 4 plus 2x. I can distribute. So I would get 8 plus 4x is greater than or equal to 8 plus 4x. Hopefully we're noticing that these are the exact same thing on both sides of this. Okay, so it's going to maybe give us an unusual solution we can tell from this step right away. Okay, I'm going to subtract 4x from both sides, and again, I'm going to notice my variables are going to cancel out. Okay, so I'm going to have 8 is greater than or equal to 8, and of course, 8 is greater than or equal to, it is equal to 8, so that's a true statement, so it would be all real numbers. Now, the way a graph's going to look with all real numbers is it's going to be a double-sided arrow that goes both ways. Okay, so no solution, you don't put anything on the graph. All real numbers, you need a double-sided arrow that goes both ways. Okay, so here's a couple of examples of all real numbers, no solution. Okay, again, notice in both of them our variables got canceled out. That should be our first alert that we're going to have an unusual solution. Okay, number 3, I have 25 minus 2n is less than negative 2 times n minus 9. I'm going to distribute. I'm going to get 25 minus 2n, excuse me guys, is less than negative 2n plus 18. I'm going to add 2n to both sides. Again, I notice my variables are going to cancel out. So I have 25 is less than 18. Well, of course, we know 25 is not less than 18. This is a false statement, which means it's no solution. Okay. Number 4, I have 8 minus parentheses 12p minus 8 close parentheses is greater than or equal to negative 12p plus 16. Okay, I need to distribute this negative sign to everything inside the parentheses. Okay, I do that by imagining that this is a negative 1, and I can distribute it to the contents within. Okay, so I have 8 minus 12p plus 8 is greater than or equal to negative 12p plus 16. Again, I want to combine like terms on this side. So I take 8 plus 8. I have negative 12p plus 16 is greater than or equal to negative 12p plus 16. Now that both sides are simplified, I can then move my variables to the left. Okay, I move this negative 12p by adding. Well, a negative 12p plus a 12p is going to, of course, cancel out and give me 0. So I would have 16 is greater than or equal to 16, which is a true statement, which would give me all real numbers as a graph there. Okay, so there's some unusual solutions that we can see with inequalities. Remember, I should know I'm going to be getting an unusual solution when there is no variable, when my variable gets canceled out. Okay, and if I could be an operation, I would be subtraction because I like making a difference. There's a little positive little quote for you there that's related to math for that section, guys, and that is it for this section. Okay, let us know if you have any questions.